Welcome to geometry class. Let's talk about triangle congruence by angle side. The angle side theorem says that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. Let me direct your attention to that word corresponding and point out its significance. In fact, if you look through probably a dozen textbooks on this particular issue, this particular rule, you'll probably find several mistakes in different textbooks. A lot of times they don't talk about the fact that there needs to be a corresponding non-included side. Sometimes they talk about the corresponding angles instead. But why does it need to be corresponding, and what does that mean? It means that when I look at two triangles, and I've identified two congruent angles. For instance, suppose I had these two triangles here, triangle ABC and triangle DEF. A couple pieces of information are already given in the diagram. Angle A is congruent to angle B. Angle B is congruent to angle E. And in order to apply the angle side congruence theorem, in addition to those two facts, I need to know that a non-included side is also congruent. So, for instance, I haven't marked any of these because I want to sort of talk about different scenarios here, but suppose that side BC is congruent to side EF, and you can see that those are each black sides there. Suppose that those two are congruent. If that were the case, then I would be able to apply the angle side congruence theorem because these two angles are congruent to these two angles, and the corresponding non-included side is also congruent. So, what do we mean by corresponding? When I look at this set of triangles, side EF corresponds to side BC because those two sides are adjacent to angles B and E, which both have the double congruence mark. On the other hand, if I knew that side EF were congruent to side AC, those would not be corresponding sides because side AC is adjacent to the single congruence mark, whereas side EF is adjacent to the double congruence mark. So I have to make sure when I talk about the non-included side, I have to be absolutely certain that we're dealing with corresponding non-included sides. Be careful when you apply that rule. It's very easy to make that mistake. Let's take a look at the proof of the angle side theorem now. All right, we have two triangles here. I've labeled the vertices ABC in the triangle on the left and DEF in the triangle on the right. Also, I've numbered their angles for ease of reference, and there's some given information down here. Angle 1 is congruent to angle 2. So angle 1 and angle 2, those are congruent. Angle 3 is congruent to angle 4. Those are congruent, angle 1 and angle 4. Segment AB is congruent to segment DF, and that's actually indicated by the marks here. And so we'd like to try and prove, given the fact that we have two congruent angles and congruent corresponding non-included side, is it absolutely necessary? That is, can we prove that triangle ABC is congruent to triangle DEF? Let's start with a couple of the givens. We can see that angle 1 is congruent to angle 2. That's a given. We also see that angle 3 is congruent to angle 4. That's a given. At this point, it may be tempting to pull in the third given, but instead we'll go in a slightly different direction. Notice that angle 5 must be congruent to angle 6 by the third angle theorem. Okay? As soon as we've established that, what we've basically done is said, hey, listen, all three of the corresponding angles in the two triangles are congruent. All right, next let's pull in that third given. Segment AB is congruent to segment DF. And then finally, we can see that the two triangles must be congruent by the angle side angle congruence postulate. So we rely on the angle side angle congruence postulate to prove the angle side congruence theorem, and that makes sense. Remember, theorems are always shortcuts. If you forgot the theorem existed, you could always work through the proof just as we did it right here, and you'd still end up in exactly the same place. Be sure to work through a couple problem examples, and as always, if you have any questions, send me an email.